Hello everyone, welcome back. In this video, I will be covering section 2.4, the precise definition of limit. Earlier, we saw in section 1, velocity and tangent problems. The second section, we saw the limits, left limit, right limit, and then vertical asymptote definition, limit being infinity. Then definition of vertical asymptote. And then the third section, we saw laws of limit, and we did applied the laws of limits to evaluate certain limits. And then there are certain techniques that we use in evaluation of the limits, like factoring, rationalization, and common denominator, and so on. In this section, we are going to focus on how we can interpret the definition of a limit. This is known as precise definition of a limit. To motivate the precise definition of limit, let's consider the function f of x equal to 2x minus 1 whenever x is not equal to 3, and it's equal to 6 when x equal to 3. If you look at the graph of this is the way it will look, because it's a piecewise defined function. If you notice that whenever it is not equal to 3, it is defined as a straight line with the y-intercept -1 and the slope 2, but it is equal to 3, 6. At the point 3, it is actually a solid point here whose coordinates are 3, 6. So it's whenever x is not equal to 3, it is a line. At x equal to 3, it is a point. So this means that 3, 6 is a point on the graph. So x equal to 3 and y equal to 6. Solid point. Intuitively, it is clear when x is close to 3 and x is not equal to 3, then f of x is close to 5, isn't it? So suppose if I graph a line at x equal to 3, then when x is close to 3, when x approaches 3 from either side, f of x will approach, or the y value will approach the value 5. That's what it means. When x approaches 3 on either side, f of x approaches 5. So we write this intuitively as limit of f of x as x approaching 3 equal to 5. This is how we define the limit. To obtain more detailed information about how f of x varies when x is close to 3, we ask the following question. How close to 3 does x have to be so that f of x differs from 5 by less than 0.1? So we say that here f of x approaches 5. So does it mean that will 5.1 be considered close to 5, or will 4.9 be considered close to 5? So because we are using the word f of x approaches 5, then it depends on what the difference between f of x and 5 is. Is 0.1 acceptable, or 0.2 difference is acceptable? So we call the difference between f of x and 5 as epsilon. We use the letter epsilon for that. And then knowing that if that f of x has to differ by 5 by say 0.1, then how close does x should be to 3? So what is the difference between x and 3 on the x-axis, which we call it as delta? Okay, this is what we need to find out. This is something that will be given. Okay, so let's see here. To obtain at how close to 3 does f have to be so that f of x differs from 5 by less than 0.1. The distance from x to 3 is absolute x minus 3, and the difference from fx to 5 is absolute x, f of x minus 5. It can be above 5 or it can be below 5. So that's why we take the absolute value. The difference is taken as epsilon. The problem is to find the delta such that when the difference between f of x to 5 is less than 0.1, if absolute x minus 3 is less than delta, but x not equal to 3, If absolute x minus 3 is positive and not equal to 3, so an equivalent formulation of our problem is to find a number delta such that absolute f of x minus 5 is less than 0.1 if absolute x minus 3 is less than delta. So if we choose, if absolute x minus 3 is chosen as, so the idea is we need to find out how close x should be to 3. We have to find out this difference, how close x should be to 3, so that f of x differs from 5 by 0.1. So you can take here 5.1, this will be 4.9, so that this distance is uniform, that is equal to 0.1. I call that one as epsilon. Okay, this distance is 0.1. If f of x to 5, the difference is 0.1, what is the difference between x and 3 on the x-axis? So if we choose the difference to be 0.1, then we can choose our delta to be equal to 0.1 over 2. So if this one, it's 0.1 over 2. This will be equal to 0.05. Correct? Okay, thus an answer to the problem is given by delta equal to 0.05. That is, the reason is, if you consider this absolute f of x minus 5, you know that in this problem f of x is 2x minus 1. So substitute 2x minus 1 minus 5, which is absolute 2x minus 6, which is 2 times absolute x minus 3, which will be less than 2 times absolute x minus 3. We consider that to be 0.05 because it's 0.1 over 2. So if you substitute that, you get 0.1. So if you choose delta, which is the difference between x and 3, to be equal to 0.1 over 2, which is 0.05, then f of x, the difference between f of x to 5 becomes less than the desired quantity. Desired epsilon. So will it be possible, whatever the number that you give, whatever the difference between f of x to 5, you want that to be, will it be possible for you to get a suitable delta? Will it be possible to find out how close that x should be to 3 is? The answer is yes. So however small you choose for epsilon, the difference between f of x and 5, you will be able to find out a corresponding delta. You will be able to find out how close that x should be to 3 is. So we are going to use the notation epsilon and delta. So what is the precise definition of the limit? Let f be a function defined on some open interval that contains a number a, except possibly a itself. Then we say that the limit of f of x as x approaches a is L, and we write limit of f of x as x approaching a equal to L. This is something that we have seen before. If for every epsilon positive, there is a delta positive such that if 0 less than absolute x minus a is less than delta, then absolute f of x minus L will be less than epsilon. So this is the limit. This is the limit definition that we have seen before. The precise definition of limit is, if for every epsilon positive, there is a delta positive such that if the difference between x and a is less than delta, then that will give absolute f of x minus L. The difference between f of x and L will be smaller than epsilon. This is true for any epsilon that you pick, which is the difference between f of x and L. So in this example given, you find out what L is, what f of x is, what a is, what delta is. Okay. So you have to look at this statement over here. go from there. So this one, x squared plus 4x minus 2 looks like f of x. And this one looks like L limit. And this one looks like epsilon. And this is A. This is delta. Right? So let's write down x squared plus 4x minus 2 for f of x. L is 10, A is 2, and delta is 0.5. What it means is, given the difference between f of x to 10, f of x to L, if that is, you want that to be smaller than 0.001, then the closeness of 2 for x, the neighborhood of 2 will be 0.5, which means this distance over here. So you can go up to 2.5 here and 1.5 over here. So x will be in this neighborhood. X is in this neighborhood. If x lies between 1.5 and 2.5, which is a neighborhood of 2, then f of x and 10 will differ by 0.001. So let's take this. This example is actually proved for you. And then we will take something similar and we'll do that problem in the exercise. Use the graph of f to find the delta such that if absolute x minus 1 is less than delta, then absolute f of x minus 1 is less than 0.2. Suppose you recap the epsilon delta definition that we just said for precise definition, and you notice that this number 1 should be L, and this number 0.2 should be epsilon, and then this number here should be A. Right? The question is, what is delta? So you know that this A occurs here on the x-axis. Then you have a neighborhood of 1, but on the right side of 1, the difference is 0.1. On the left side of 1, the difference is 0.3. Then you know that L here is on the y-axis. So L is the value of the function, y value of the function at 1. So this point is 1, comma L, right, in this case. So when x approaches 1 from either side of 1, f of x approaches 1, correct, in this case. And when we say f of x approaches 1, then there is a difference of 0.2 on either side. So it is 1.2, 1 to 1.2, the difference is 0.2. 1 to 0.8, the difference is 0.2. So that is the expression that you see here. This is for epsilon on the y. Same way, what is the difference delta on the x is what the question is. How close this x should be to 1. So we see that from the picture, you have two differences from 0.7 to 1. From 0.7 to 1. The distance is 0.7 minus 1, which is equal to 0.3. Same way, if you take this distance, 1 to 1.1, let me call the first difference as delta 1. This distance is distance between 1 and 1.1. That is going to be 0.1. I'm taking the absolute value. So the difference, the neighborhood of 1 is not uniform. In order to make it uniform, you choose delta, which is smaller than the minimum of the delta 1 and delta 2. So delta should be smaller than the minimum of delta 1 is 0.3, delta 2 is 0.1. So you also mentioned that the difference delta 1 is the distance between 0.7 and 1, which is 0.3. Delta 2, the difference between 1.1 and 1, that is 0.1. The delta is smaller than the minimum of these two, which is less than 0.1. You choose smaller of the two. And if you choose delta to be smaller than 0.1, which means you're pretty much making the difference the same, 1.1 here and here 0.9. If you choose your difference like this, in this neighborhood, this is 0.1. And so suppose you choose your neighborhood of 1 like this, on the right side 1.1, on the left side it is 0.9. Now, if you consider the neighborhood in this way, and if your x lies in this neighborhood, then the difference from here will be 0.1. The difference here would be 0.1 also. Right? So you're making the difference uniform. So if you choose your delta smaller than 0.1, then absolute f of x minus 1 will be less than 0.2. The question is, what is delta? Find the delta. So the answer is going to be delta is smaller than or equal to 0.1. Let's see the next problem. Use the graph of f to find a delta such that if absolute x minus 3 is delta, then absolute f of x minus 2 is less than 0.5. So as we did in the earlier problem, this value is the limit of f of x. This value is the difference that we desire between f of x and 2, which is 0.5. So this distance is 0.5, 2 to 2.5, and 1.5 to 2, that is also 0.5. Now, what should be the neighborhood of 3? How close x should be to 3, right? So this is our A on the x-axis. The question is, what is delta? So like we did earlier problem, so in this one, we want to choose delta 1, which is the distance between 2.6 and 3. Delta 1 is 3 minus 2.6. You can consider the difference any way you want, because it's absolute value. This is going to be anyway positive. Delta 2, similarly, is the distance between 3 and 3.8, which is 0.8. So what is the minimum? Just the minimum of delta 1 and delta 2. Delta is smaller than or equal to the minimum of 0.4 and 0.8. So delta is smaller than or equal to 0.4. So you choose your delta, which means that you can only go to the left 2.63 and the right only up to 3.4. So if you make your restriction of x in this neighborhood, if your x lies in this neighborhood of 3.4 on the other side, on the right side, 2.6 on the left side, you're making the distance uniform. So in that case, then f of x to 2, this is your L, right? L equal to 2. The distance between f of x to 2 will be definitely smaller than 0.5. Okay? So the answer is choose delta smaller than 0.4. Okay. There is a similar problem here. We can try that one too. Then let's try one of the epsilon delta definition problem, either 19 or 20. Prove the statement using the epsilon delta definition of a limit. Let's say problem number 19 here. So it's given limit as x approaching 9 of 1 minus 1/3 x equal to -2. So you know that in our definition, this means x approaching a, f of x equal to L, right? So we can identify what f of x is. F of x equal to 1 minus 1/3 x, L equal to -2, and a, this a equal to 9, then L equal to -2, and of course f of x equal to this guy here, 1 minus 1/3 of x, a equal to 9. So the precise definition says that given epsilon positive, we need a delta. We need to find out a delta positive such that if 0 less than absolute x minus 9 is less than delta, then absolute f of x minus L, f of x minus L, L is -2, will be automatically less than epsilon, correct? So this is f of x, and this one is L, this one is A. All right. Now, if you consider the expression 1 minus 1/3 of x minus of -2 less than epsilon, so this means that, let's expand this, but 1 minus 1/3 of x minus of -2 less than epsilon. What does that mean? It implies an implied by, right? The 1 minus 1/3 x plus 2 less than epsilon. This implies an implied by 1 plus 2 is 3 minus 1/3 x is less than epsilon. The goal is, as we said earlier, if you want the difference to be 0.1, f of x to L to be 0.1, what should be your choice of delta, which is in terms of 0.1? So we are getting a relation in the earlier example, the very first example, we said that if epsilon was 0.1, then the delta was 0.1 over 2. This is not always 0.1 over 2. It's not always epsilon divided by 2. It could be a value related to epsilon. So that is our goal. We have to find out something related to epsilon because epsilon is something given to us. So you are finding a new value in terms of something given to us. Okay. So it is 3 minus 1/3 of x is less than epsilon. What does that mean? This means if I pull up, what is my goal now? I want to bring in this x minus this expression somehow, right? In terms of epsilon. So I need to work towards that. So I can write this as if I pull out a negative 1/3 outside, I'm pulling out a negative 1/3. So I will write this as x minus 9. So now I got that x minus 9 somehow. Is this right? Distribute and see. What is negative 1/3 times x minus 9? That is negative 1/3 x plus 3, isn't it? Negative 1/3 times 9, which is exactly this. So I can write 3 minus 1/3 x as negative 1/3 pulled out times x minus 9 less than epsilon. This would mean or implies an implied by. Both ways it is true. So we can write this as absolute x minus 9 less than, if you move the 3 to the other side. By the way, this is absolute negative 1/3 is 1/3. So it is 1/3 absolute x minus 9 is less than epsilon. This implies and implied by absolute x minus 9 is less than 3 epsilon. So the goal is what we need to get, this absolute x minus 9 less than delta. What is that delta? So now we are getting something in absolute x minus 9, but something as 3 epsilon. So if you choose delta to be 3 epsilon or smaller than 3 epsilon, either way, so this is equal to 3 epsilon. So if we choose delta to be equal to 3 epsilon, then what will happen? Then absolute x minus 9, so absolute is always positive, absolute x minus 9 less than delta would mean absolute x minus 9 is less than 3 epsilon, correct? Because we are choosing delta equal to 3 epsilon, correct? So it will be less than 3 epsilon. This would mean if I divide 1/3 of absolute x minus 9 will be less than epsilon. If I divide both sides by 3, which is exactly similar to this step, this means that negative 1/3 times x minus 9 would be less than epsilon, which would mean, so the previous step, so it will be 3 minus 1/3 of x would be less than epsilon, which we are pretty much retracing the steps, which can be written as 1 minus 1/3 x minus of minus 2 less than epsilon. This implies and implied by, this is nothing but f of x minus L minus L is less than epsilon. So pretty much, if you choose, so the choice of delta should be equal to 3 epsilon or smaller even. So if you choose like that, then the difference between f of x to negative 2 will be smaller than any epsilon given. So try to practice the problems that are there in the additional suggested problems here. Then you can also refer to other videos that I will be posting. And then for my next video would be on section 2.5. Please follow me for the next video.